Hi, and welcome to section 5.6, proving that a quadrilateral is a parallelogram. Our objective is, of course, to prove that a quadrilateral is a parallelogram, and our homework is on page 252 to 254, 4 to 14 evens, and 17 through 18. We have 5 ways to prove that a quadrilateral is a parallelogram. Our first way: if both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. Our second way: if two pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Our third way: if one pair of opposite sides of a quadrilateral are both parallel and congruent, then the quadrilateral is a parallelogram. If the diagonals of a quadrilateral bisect each other, the quadrilateral is a parallelogram. And last but not least, if both pairs of opposite sides of a quadrilateral are congruent, the quadrilateral is a parallelogram. Let's draw out the 5 ways of proving that a quadrilateral is a parallelogram. First and foremost, our first theorem said we knew the quadrilateral was a parallelogram if we knew opposite sides were parallel. As long as we know that both pairs of opposite sides are parallel, we know it's a parallelogram. For our second way, if both pairs of opposite sides were congruent, we knew that it was a parallelogram. That was our second way. For our third way, if we know one set of opposite sides is both parallel and congruent, so it has both tick marks on it, we knew it was a parallelogram. Our fourth way: if we knew that the diagonals bisected each other, we knew it was a parallelogram. And last but not least, if both pairs of opposite angles are congruent, we knew that it was a parallelogram. Okay, so here's our first example. We have a proof, so here we go. If you want, you can start this on your own and always pick up. Now, there's definitely more than one way to do this, so if your answer doesn't match mine and you think there might be something going on, ask me in class. Here we go. We know that ACDF is a parallelogram, and angle AFB is congruent to angle ECD. Those are our givens. Mark that in. AFB is congruent to ECD. Now, the next thing that I would do is I would say that angle A is congruent to angle D. Opposite angles of a parallelogram are congruent. Next, I would say that AF is congruent to DC. Opposite sides of a parallelogram are congruent. Now that's enough to say our triangle congruency. I would say triangle AFB is congruent to triangle DCE by angle side angle. Now, I'm going to carefully select my CPCTCs. We have lots of options here, and those options would actually work. What I'm going to say is that FB is congruent to EC by CPCTC. I'm also going to say AB is congruent to ED by CPCTC. Now, from that big original parallelogram, I know that FD is congruent to AC. Opposite sides of a parallelogram are congruent. I'm just going to be this big side here, matched up with that big side there. I'm going to say that BC is congruent to FE by subtraction. And now, when I look at FBCE, I know it's a parallelogram. FBCE is a parallelogram. for a reason. If both pairs with opposite sides of a quadrilateral are congruent, it's a parallelogram. Here's our next example. It's an algebraic one. We're given quadrilateral QUAD with angles as shown. We're going to show that the quadrilateral is a parallelogram, so we're not going to do a proof. Now, I kind of want to bring you back to algebra. Make sure you remember these monomial properties. So here's the first thing. We need to simplify x squared raised to the 5th power. And when we have exponents raised to a power, we multiply. That makes it x to the 10th. Therefore, these opposite angles are congruent. Next, I'm going to distribute 3x to both pieces. And when I do that, I get 3x to the 3rd. When you multiply letters, you add their exponents, minus 15x squared. And again, we get opposite angles are congruent. Showing that it's going to be a parallelogram, we have if opposite angles of a quadrilateral are congruent, it's a parallelogram. Okay, so we're on our last example. We're given that we have a parallelogram, NRTW, that NX is congruent to TX, WV is congruent to PR. We're trying to prove that XPSV is a parallelogram. You need to press pause and see what you can do. Alright, here we go. Again, we got lots of different ways to think about this. Here's the way I'm going to take it. I'm going to say angle N is congruent to angle T for a reason. Opposite angles of a parallelogram are congruent. I'm also going to say angle W is congruent to angle R. Same as 4. Next, I'm going to say that TR is congruent to WN. Opposite sides of a parallelogram are congruent. TR, WN. So by subtraction, WX is going to be congruent to SR. Next I'm going to say WT is congruent to NR. The reason, same as 6, which is going to be this big side here, matched up with this side here, which means that VT is congruent to NP, again by subtraction. And now I have two sets of congruent triangles. Triangle XWV is congruent to triangle SRP. The reason, side angle side. My next pair of congruent triangles, triangle BTS is congruent to triangle PNX, again by side angle side. Now, my CPCTCs. I'll take my proof up here. I'm going to have XP is congruent to VS by CPCTC. I'm also going to have that XV is congruent to PS by CPCTC. Which means XPSV is a parallelogram. My reason, if both pairs of opposite sides of a quadrilateral are congruent, parallelogram. So here's the answers to the homework. Again, we had 4 through 14, the evens, and 17 and 18. Now, if you have any questions about any part of this lesson, this is a one-day lesson. You need to make sure you're asking it in class. Other than that, have a good one.